Okay, we are doing experiment number 5, which has to do with Kirchhoff's law for voltage law. Okay, so first thing we need to do is find a 1.2, a 2.2, and a 3.3 resistor. We think we have them. In table 5.1 we're supposed to measure them. So if you'd be so kind as to measure the resistors one at a time. And we have set our meter, our multimeter, to be an ohm meter, so it should do that for us. And that looks like our 3.3 guy. All right, well, that's close enough. Okay, and the next guy might be a 2.2. Yep, that's a 2.2. And the last guy should be a 1.2. And he's a 1.2. Now I paid all of $7 for 1,000 of these particular resistors, so that's good. Okay, so now we have a circuit to make, figure 5-1, so we're going to do that next. We're going to switch our power supplies back to the guy on the bottom, so we'll hook our red wire up to red and our black wire up to black. Now you may ask why I did that. The fancier power supply on the bottom doesn't go low enough in voltage, and so in the last experiment we had to get below the 1.4 volts that the digital guy is going to go, and so we had to get a different power supply to do that experiment. I forgot to tell you that, but that's okay. Now we're going to go and hook up the new power supply. Okay, now this time we're going to take amp meter readings and the amp readings at different spots. So we're going to follow a little different pattern on the proto board. So we'll take the 1.2K resistor and go from the red to someplace on the board. And then we'll take the 2.2 guy from the last guy we went to and then to someplace else on the board. And then we'll take the 3.3 guy from that spot to the negative side. Not that negative side though, that negative side, right. Because our amp meter is going to be disconnected from where it's hooked up now, and we're going to hook it up in different places. So we want to be at 10 volts, so have our power supply give us 10 volts. Okay, good enough. And now we want to have the current at point A, which is between the power supply and the 1.2K resistor. So the way we're going to do that, well, we already have it. So we have hot going into our amp meter. So what we're going to do is we're going to pull the resistor out and hook the negative side of our amp meter to the other side of that resistor. And what that's going to do is that's going to give us the current at point A. And we look and we see that we have 1.5 milliamps flowing. Now, we all know that current in a series circuit has to be the same, but it's asking us to do go and measure it at the other point, so that's what we're going to do. So disconnect the amp meter, and we're going to go and measure the current at point B, right there. So now we're measuring the current at point B, and what did I do? I put it in the wrong spot. And, oh wow, it's 1.5 milliamps. Isn't that special? Okay, then we're going to measure it at point C. So we'll disconnect the ammeter and look at point C. Put the red guy on if you would. No, that black guy's fine. No, yeah, right there. Yeah. That point C. Oh wow, we still have 1.5 milliamps. I'm so happy we did that. Okay, one more time. We're going to go to point D. So just disconnect the ammeter. And we'll go to point D and try one more time to see if we can get the same exact reading. So we're off there, and we'll take a wire, stick it in the negative side. Okay, there we go. And oh wow, it's different. It's negative now. That's because our glorious technician put the black guy on the red and the red on the black. So he's about to turn it around and change it the other way. And maybe we can get to the wire. Never can tell. Okay, there we go. Isn't that awesome? 1.5 milliamps in every spot where I measure the current, A, B, C, and D. That is just so wonderful. I'm just so happy about that. Okay, so what are we doing next? We're going to do the same thing at 1.5 volts and the same thing, and then we're going to do some calculations. So it looks like we're done. Have we taken all the data we need? I think we have. Yeah, pretty much. Okay. And so that means we're done with lab 5.